Hello, and welcome to this demonstration of a paired samples t-test using SPSS. Today I'm going to analyze data from bowling coaching study to determine whether a single 15-minute coaching session can significantly improve student bowling scores. Um, so my research question is, does a 15-minute individual coaching session with an expert bowler significantly improve students' bowling scores? My null hypothesis is there is no significant difference between pre-coaching and post-coaching bowling scores. Alternative hypothesis is there is a significant difference between pre-coaching and post-coaching bowling scores. So first thing I did was I looked at my data and I need to know uh, if my data is normal. So I'm going to go to transform compute variable. Under compute variable, I'm going to add game one minus game two. I'm going to title it diff, and I'm going to hit OK. That's going to compute and give me a new category here, a new column called diff. I'm a diff category now. I want to see if see how this data is normal. So I'm going to go to Analyze, Descriptive Statistics, Frequencies. I'm going to put in my diff, and then I want to look at a histogram. I want to show the normal curve on my histogram. I'm going to hit OK. That's going to give me my first data sort. But sorry, it was hidden. All right, on my frequency table, and now I have my histogram. It is generally normal this, but I am going to go back and look a little deeper into that. So I'm going to go to Analyze. I'm going to go to Descriptive Statistics, and I'm going to go down to Explore, and I'm going to run the same model again, but this time I'm going to hit Plots. I don't want either of these. I want a histogram. I don't need a stem and leaf. And I want the normality plots with tests, and that should give me my Shapiro-Wilks test. Hit OK. Let it run. Okay, so now my test for normality is here where I got my Shapiro-Wilks. Degrees of freedom is 20 and my significance is 0.337. And since that is greater than 0.05, I know that my data is normal and I can run a P test, a T. I can run my paired samples T test on this data. So now I'm going to go back here and I'm going to go to Analyze. Under Analyze, I'm going to hit Compare Means. So I'm going to go Compare Means. I'm going to go down here to my paired samples t-test. All right, my variable, I'm going to put game one in variable one. I'm going to put game two in variable two. All right, and then I'm going to hit OK. And this is going to give me my paired samples t-test. The paired sample statistics table shows the descriptive statistics for both conditions. Okay. Game one and game two. So game one before coaching, students had a mean score of 90 points with a standard deviation of 13.541. And after the coaching session in game two, the mean score increased to 94.95 with a standard deviation of 14.32. This represents an increase of 4.95 points on average. My key values, game one, my mean is 90. My standard deviation is 13.54 in game two. Uh, Mean is 94.95 with a standard deviation of 14.32. All right, so now I don't look at this correlations chart, but instead I go down here to my paired samples chart. The paired samples test table provides my statistic. The statistic is my T, my degrees of freedom. My T19, what equaled negative 1.685, negative 1.685 was my T value. My degree of freedom was 19, and my two-sided p-value was 0.108. So the degrees of freedom are 19, and that's calculated with n minus 1, or 20 minus 1 equals 19. And most importantly, the two-tailed p-value is 0.108. And then using my alpha level of 0.05, this p-value is greater than 0.05, which means I failed to reject the null hypothesis. The 95% confidence level suggested with my uh, 0.05 for the mean difference ranges from 11.10 to 1.20 points. So that also includes 0. My delta, my rate of change, was game 2 minus game 1 divided by game 1 times 100. So I substitute my values in. So I put in my 94.95 minus my 90 mean, and then divided that by 90, times it by 100. So that gave me 4.95 divided by 90 times 100, which equaled 5.50. The coaching sessions resulted in an average improvement of 5.50% in bowling scores. While this represents just a small increase, we must consider whether this difference is significant. And so now to state my conclusions. A paired samples t-test was conducted to evaluate whether a 15-minute individual coaching session would significantly improve students' bowling scores. The analysis compared scores from game 1 pre-coaching with a mean of 90 and a standard deviation of 13.54 to game 2 post-coaching mean 94.95, the standard deviation of 14.32. The results indicated that the difference of 4.945 points was not statistically significant. My T of 19 equaled negative 1.69 with a P equal to 0.108. And based on my findings, we failed to reject the null hypothesis, and there's insufficient evidence to conclude that a single 15-minute coaching session significantly improves bowling scores in this population. Ultimately, to summarize, what I found out was that we conducted a paired samples t-test to evaluate the effectiveness of 15-minute bowling coaching session, and while we observed a 5.5% improvement in scores, this difference was not statistically significant at the 0.05 alpha level. So the effect size was small to medium, and practical considerations suggest that while the coaching shows promise, we would need additional research with a larger sample to draw firm conclusions. Thank you for watching this demonstration of paired samples t-test analysis in SPSS.